Hello students, welcome to the third lecture on the lecture series on relationship between numbers. Okay, so what we have previously learned is we have learned what are patterns, what are sequences, what are types of sequences like arithmetic progression, geometric progression, harmonic progressions, and the type of numbers that are like composite numbers, prime numbers, criteria to know whether a number is prime number or not. Okay, so next what we are going to see is the divisibility rules, okay, for different numbers, whether a number is divisible by another number or not, number is divisible by 3 or 6 or 9 or not. We have already learned about the divisibility by 11 up to 11, right? So what we will further learn is we will learn all the new rules, that is after 30, like 11, like 12, 13, 14, like this. Okay, so concepts and types of problems on relationship between numbers. Okay, so let's continue the divisibility rules. So divisibility by 12. Okay, when we can say that a number is actually divisible by 12 or not. Okay, a number is divisible by 12 if it is divisible by both 3 and 4. So if you are given a number x, y, z, w, let's say this is the unit digit, 10 digit, 100 digit, 1000 digit. Okay, and how can you say that if this number is actually divisible by 12 or not? So what you need to see is that if this number is divisible by 3 and 4 or not. So for 4, you know that you need to take the last two digits, that is zw, and see whether it is divisible by 4 or not. Okay, if yes, then we will further see if it is divisible by 3 or not. So how can we see that if this is divisible by 3 or not? By adding all the digits. Okay, let x plus y plus z plus w. If this number is divisible by 3 and zw, that is the last two digits, are divisible by 4, then what we can say is the number is divisible by 12. So let's see an example, 240. Okay, let's see whether it is divisible by 12 or not. So consider the last two digits, okay, like 40, and you know that 40 is divisible by 4, right? And let's see it is divisible by 3 or not. 2 plus 4 plus 0, this is equal to 6, and 3 divides 6. Okay, so for 3 it is also true. So since both 4 and 3 divide this number 240, okay, so we can say that 12 also divides 240. Okay, so another example is 4320. Okay, so here you can see that the last two digits are 20. Okay, 2 and 0, 20. So this is divisible by 4, as 4 into 5 is equal to 20. And what we need to further evaluate is whether 4320 is divisible by 3 or not. Okay, so 4 plus 3 plus 2, that is equal to 0 plus 4 plus 3 plus 2, that is equal to 4 plus 3 plus 2 is equal to 9. Okay, so you know that this by 3 is equal to 3. Okay, since this is divisible by 3, that is this number is divisible by 3. Okay, so what we can say is 4320 is divisible by 12. Okay, so let's see the divisibility by 13. Okay, so whether a number is divisible by 13 or not, how to know? So first step we need to check is take the last digit of the number, multiply it by 4. Okay, first what we did was take the last digit of the number, then multiply the digit by 4. Okay, then what we need to do is add the result to the remaining part of the original number. So if the number is 1 2 3 4, okay, then what we need to do is take the last digit, that is 4. Okay, and multiply it by 4. So 4 into 4 is equal to 16. What is the remaining part? This is the remaining part. Okay, so what we need to do is 1 2 3 and add 16 to it. Okay, so what we got is 139. Okay, so this is what we got. Okay, so if the result is divisible by 13, okay, so if this is divisible by 13, then or we end up with 0 or a known multiple of 13, then the original number is divisible by 13. Since this is not divisible by 13. So this implies that 1, 2, 3, 4 is not divisible by 13. Okay. So for example, another example, 520. Okay. See the last digit here and we multiply 4 with it. So 0 into 4 is actually 0. And we add 52 plus 0. That is 52. And let's see whether 52 is divisible by 13 or not. Since this is divisible by 13, so this implies that this is divisible by 13. So what we can say here is 13 divides 520. Okay, and the remainder will be 0. Okay, so what we did was take the last digit, that was 0, multiply it with 4, then what we got was 0, and then add it to 52. Okay, so then what we did was added 52 to 0, and then we got 52. Okay, that was the third step. Okay, then what we did was checked whether 52 is divisible by 13 or not. Okay, let's take another example. Okay, let's say 640. Okay, so for this, and again you take the last digit and multiply it by 4 is equal to 0. Okay, and what you do next is you add this to the remaining part. So 64 plus 0, so that is equal to 0. Sorry, not 0, 64. So what we need to check next is whether this is divisible by 13 or not, and this is clearly not divisible by 13. Okay, not divisible by 13. Okay, so this implies that 640 is not divisible by 13. Okay, let's check the divisibility rule for 14, that is whether number is divisible by 14 or not. So if a number is actually divisible by 14, okay, it is divisible by both 2 and 7. Only two things that you need to check is whether the first thing is it is divisible by 2. Okay, that is it is even. Okay, the next thing that you need to check is it is divisible by 7. Okay, so for example 686 here. Okay, so in order to check for the divisibility by 2, what you need to do? So all that you can need to do is take the last digit and check whether it is even or not. So since 6 is even, so the whole thing is even. So this implies that divisible by 2. Okay, so the first step is conquered now. Okay, so we got it. 2 is actually divisible. Okay, so the number is divisible by 2. So what we need to look here. Okay, so next what we need to do is check for divisibility by 7. Okay, so how to check for the divisibility by 7? What we need to do? We need to take the last digit. Okay, so what was the last digit? Was 6. Okay, so we took the last digit here and then doubled it. Okay, so 6 into 2. 6 into 2 is equal to 12. Then what we need to do? Then subtract that amount from the rest of the number. So 686 was the number. Okay, so 6 was taken and multiplied by 2 or doubled. Then what we need to do is minus 12. Okay, subtract it. So what we are left with is 56. Okay, here we have got 56. So now look at 56. Is 56 divisible by 7? Okay, so 7 into 8 is equal to 56. So actually 7 divides 56. So yeah, we got the second part cleared. So 686 is divisible by 14. Okay, so divisible by 14. Okay, here you can see that 686 is actually divisible by final answer. Okay, and actually you can see that 686 by 14 is actually 49. and we have also proved it here by proper method. Okay, this was done by calculating manually. Okay, this was using trick. How can we check for the divisibility by 15? Okay, whether number is divisible by 15 or not. So we take that number, and what we need to check is check for the divisibility by 3, divisibility by 5. So what we have previously learned was we add all the digits, and then what we need to check that the sum is divisible by 3 or not. If it is divisible by 3, then the whole number is divisible by 3. And for 5, what we learned was whether the last digit is 0 or 5. If it is 0 or 5, we can straightforwardly say that the whole number is actually divisible by 5. Okay, so for example, let's take 1365. So how can we say that 1365 is divisible by 15 or not? What we need to check is we need to add these digits. So 1 plus 3 plus 6 plus 5. So the first step is adding all the digits, that is 6 plus 5 plus 3 plus 1. So 6 plus 5 is equal to 11 plus 3 is equal to 14 plus 1 is equal to 15. So this thing is actually divisible by 3 since 3 into 5 is equal to 15. Okay. So first step is conquered. Okay. So let's check for the second step, that is whether it is divisible by 5 or not. Okay. So in order to see that whether this is divisible by 5 or not, what we need to check is the last digit here. Okay. It is 5 or 0. So this is 5. So yes, since last digit is 5. So this implies that 1365 is divisible by 5. Okay. So what we can imply from these two things is 1365 is divisible by 15. Okay. So let's see other divisibility rules. So for divisibility by 3, what we did was we added all the digits. Okay. And we checked whether this is divisible by 3 or not. So yes, yes. Then again what we did was 1365 is divisible, the last digit is 5, so this is divisible by 5. Therefore the whole thing is divisible by 15. Okay. So let's check for the divisibility rule for 16. So whether a number is divisible by 16 or not. So a number is divisible by 16 if the last 4 digits form a number divisible by 16. So if you are given a number, let's say 36 4691600. Okay. So this is a large number. Okay. 1 2 3 4 5 6 7 8 9. 9 digits are there. Okay. So what you need to check is you need to check for the last 4 digits. Okay. So here I cleverly chose 1600. Okay. What are the last 4 digits? 1600. Okay. Whether this number is divisible by 16 or not. By 16 or not. Okay. So since yes, so the whole number is actually divisible by 16. For example, another example like 12048 is divisible by 16 because the last 4 digits, that is 2048, form a number divisible by 16. Okay. So let's check for the divisibility by 17, the divisibility rule for 17. So what we need to do, there are 4 steps involved in this. Okay. So what we need to do is remove the last digit of the number. Okay. And then multiply the digit by 5. Okay. First, let's say we have 1001. Okay. This is a number. So what we need to do is remove this last number. Okay. We removed it. Okay. What we got was 1. So then what we need to do is we multiply it by 5. So multiply it by 5. So what we are left with is 5. Okay. So then what we need to do is we subtract the result from the truncated original number. Okay. So the truncated original number is this. Okay. From which we have removed 1. So 100 minus 5. What we are left with is 95. Okay. So if the result is divisible by 17. Okay. Or if it reduces to 0. Then the original number is divisible by 17. So what we need to see is whether this number is divisible by 17 or not. Okay. Since this number is actually not divisible by 17. Not divisible by 17. So what we can conclude is 1001 is not divisible by 17. Okay, straightforward. So another example is given here. Let's say 238. Okay, using this thing, what we did was we took 8 out of it. Okay, and then multiplied with 5. 8 into 5, that is 40. Then what we did was we got 23. Okay, the truncated part. Okay, then what we did was 23 minus 40 is equal to minus 17. Okay, so what we need to see is minus 17 divisible by 17? Yes. 17 into minus 1 is equal to minus 17. Okay, so yes, so hence this number is actually divisible by 17, and actually 238 by 17 is equal to 14. This is a whole number and there is remainder 0. Okay, so let's see whether number is divisible by 18 or not. Okay, we are given a number and we need to check whether it is divisible by 18 or not. Okay, so whether number is divisible by 18. So if it is divisible by both 2 and 9, the only criteria you need to say whether the number is even, and check whether it is divisible by 9. That is sum of the digits and check whether the sum is divided by 9 or not. Okay, that is the only thing that you need to check. So here we have an example 972. So what we need to do is, since 2 is in the last digit, what we can say that this is even. Okay, so one thing is clear. So the second thing is add all the digits, that is 9 plus 7 plus 3, sorry, plus 2 is equal to 9 plus 9 is equal to 18, which is actually divisible by 9. Divisible. So this implies that by these two things, what we can imply is 972 is actually divisible by 18. Okay, so let's take another example, that is 1001. Okay, so you can sum up this, and 1 plus 0 plus 0 plus 1 is equal to 2. This is not divisible by 9. So what you can imply is this imply not divisible by 9. Okay, so for that, here C, we checked for the last digit and checked whether it is even or not. It was even, and then we checked for the divisibility by 9. What we did was we summed it up and we got 18. Since 18 is divisible by 9, so 972 is divisible by 9. Therefore 972 is divisible by 18. Okay, that was the conclusion, final answer. So let's check the last divisibility rule, that is divisibility rule for 19. Okay, whether number is divisible by 19 or not. So again, what we do is we check for 4 criterias. Okay, so first what we do is remove the last digit from the number. Let's say, and let's take that number again. Let's take 2001. Okay, what we do is remove the last number. Okay, and keep it aside. Okay, we kept it aside 1. Okay, we removed it from here. Okay, so then what we do is we multiply that digit by 2. 1 into 2. So what we are left with is 2. Okay, then add the result to the truncated original number. Then we added 2 to it. So 202. That is what we are left with. Okay, then the resultant number is divisible by 19, or if it reduces to 0, then the original number is actually divisible by 19. Since if divided by 19, when divided by 19, we are actually left with a remainder, what? Into 10 is equal to 190. So what we are left with is 12. Remainder is 12, that is not equal to 0. Since 19 does not divide 202. This implies that 2001 is not divisible by 19. Okay. Let's take another example, that is 399. To see whether it is divisible by 19. Okay. So let's take all the 4 criteria or rules, remove the last digit. So after removing this part, what we are left with is, 39. Okay. And what we did was multiply 9 with 2, or we doubled it. Okay. Then we got 18. Then we added them and we got 57. And what we need to check is whether 57 is divisible by 19 or not. Yes, as 19 into 3 is equal to 57. So 399 is actually divisible by 19. Okay, we can conclude it from here. Let's see some important formulas. Okay, so the first important formula is sum of the first n natural numbers. Okay, so we have previously learned what are natural numbers: 1, 2, 3, 4, and so on. Okay, what we want to know is sum of the first n natural numbers. So if they are, we all know that natural numbers are not finite. Okay, they are infinite. So at some point there comes a number n. So let's see, 1, 2, 3, 4, so on. Then comes n, and then comes n plus 1, and so on. So if we want to take sum of those, they're like 1 plus 2 plus 3 plus 4 plus 5 plus afterward numbers, then n minus 1, then plus n. Okay, if I want to know the sum up to n numbers, okay, here we have sum up to n numbers. This is equal to Sn here. Okay, this is nothing but actually equal to n into n plus 1 by 2. Okay, in higher mathematics, we use mathematical induction to prove this formula. Okay, so right now what you can do is, you can just remember this. Okay, this is a very important formula and very useful one too. Okay, so let's say I want to know the sum of the first 7 natural numbers. Okay, let's say n is equal to 7. Okay, so how will I calculate it? So n, so S7 is equal to 7 into 7 plus 1 by 2. That is actually equal to 7 into 8 by 2. Okay, so this is equal to 7 into 8 by 2. 7 into 4 is equal to 28. So you can individually add. Okay, so 1 plus 2 is equal to 3. 3 plus 3 is equal to 6. Okay, 6 plus 4 is equal to 10. 10 plus 5 is equal to 15. Okay, so 15 plus 6 is equal to 21, and 21 plus 7 is equal to 28. So you can manually also verify it that these are actually true. Okay, so what is the second important formula is the sum of the squares of the first n natural numbers. Okay, you have natural numbers here. Okay, so what we are getting is, we have a sequence of squares of natural numbers, that is 1 square, 2 square, 3 square, 4 square, and 5 square, and so on. The sequence is of the squares of natural numbers. Okay, and then what we want to know is, we want to calculate. At some point there will come a number n square. Okay, and then n plus 1's whole square, right, and so on. Okay, as it is not finite, since natural numbers are not finite, this sequence will also be not finite. Okay, so S n square will be is equal to 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus n minus 1 whole square plus n square. Okay, this is what we call as S n square. Okay, this thing here. Okay, so let's say we want to calculate for S7 square. Okay, so what it will be equal to? So by the formula, what it is equal to is 7 into 7 plus 1 into 2 into 7 plus 1. Okay, whole by 6. So this is equal to 7 into 8 into 15 by 6. So by 6, what you can see here is, this is actually equal to 7 into 4 into 2 into 3 into 5. Okay, 3 into 2. So 3 into 2 are cancelled here. Okay, so what we are left with is 7 into 4 So what we are left with is 7 into 4, 7 into 4 into 5. That is equal to 4 into 5 is equal to 20 into 7 is equal to 140. Okay, this is the answer. Okay, we can also manually add and verify the same method. Okay, so the third important formula is sum of the cubes of the first n natural numbers. So we have the sequence 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, n minus 1 cube, n cube, n plus 1 cube, and so on. Okay, so what we want to calculate is Sn cube. 1 cube plus 2 cube plus n minus 1's whole cube plus n cube. Okay, this is what we want to calculate. So let's calculate S7 cube. So this is equal to, by using the formula 7 into 7 plus 1 whole by 2 whole square. Okay, so this is equal to 7 into 8 by 2 whole square. This is equal to, so 7 into 4, 28 square. 28 square. So what was the sum of the first n natural numbers? So Sn is equal to n into n plus 1 by 2. So what is the sum of squares of first n natural numbers? It is n into n plus 1 into 2n plus 1 whole by 6. Okay. And what is the sum of the cubes of the first n natural numbers? So it is Sn cube. That is n into n plus 1 whole by 2. It's whole square. Okay. This thing is whole square. So basically Sn cube is nothing but actually Sn cube is equal to Sn's whole square. Okay, you can see that Sn is here, n into n plus 1 whole by 2, n into n plus 1 whole by 2. So another relationship is here. Okay, these two are same actually. You can observe it from here. Since this thing here is Sn. Okay, so we have now concluded all the divisibility rules up to 19. Okay, that's enough. And there are also rules for further numbers like for 21, 22, but we don't need them very often. Okay, up to 19 it is enough. Up to 10 it's compulsory. Okay, but it's really will be a good idea to remember all the rules and criteria for divisibility up to 19. Okay, and these three formulas that you can see here, 1, 2 and 3, that is sum for the first n natural numbers and sum of the squares of first n natural numbers, sum of the cubes of the first n natural numbers. These three formulas are very crucial. Okay, they can really come up at any stage of your life. Okay, and remembering these will be a huge time saver for you. Okay, think that you need to cube all the numbers and add them. It will be a hectic job. Okay, so using these formulas will really save a lot of time for you. Okay, so thank you